Alright, section 10.6, secants, tangents, and angle measure, starting on page 745. Number 1, find each measure, assume that segments that appear to be tangent are tangent. Okay, so for number 1, we want to find the measure of angle 1. So we have some lines going through, some intercepted arcs here and here. And our theorem states that the measure of angle 1, so if it's on the inside of the circle formed by two secant lines. A secant line is a line that intersects the circle in 2 points. So it intersects here and there. That's a secant line. So when two secant lines intersect, if you want to find this angle, look for this arc and then for this arc directly opposite or across from it. And you set up your equation this way. The measure of angle 1 is equal to half of the sum of those two arcs. So 86 and 134. 86 and 134 give you 220. And half of that is 110 degrees. So the measure of angle 1 is 110 degrees. For number 3, this angle is just an inscribed angle because its vertex is on the circle. So its angle measure is half of its intercepted arc. So this arc right here. So the measure of angle 2 is equal to half of 146, which just gives you 73 degrees. Number 5. So now we have a secant line here because it intersects the circle in 2 points, and a tangent line here because it intersects the circle at 1 point. So whenever you have a tangent and a secant line and they're intersecting at some point outside of the circle, well, that angle is just going to be equal to half of the difference of the two intercepted arcs. Basically, think of this as a mouth and the two arcs that are inside of that mouth. So that would be this arc and this arc. Okay? So the measure of angle R is equal to half of the intercepted arcs, and we want to put the bigger one first because we're subtracting. So the measure of, what is that, QTS minus the measure of the smaller one, so closer to the angle, 106. Or we could call that S, and there isn't a point here, so I'm just going to label this point, let's see, QRST, we'll call that U. So SU. Now we substitute in what we know. So we know the measure of angle R. This is the theorem that we have to use. So we always have to set the problem up first. We're going to use some theorem. So based off of this theorem, now we can substitute in for the measure of angle R. That's 71. We're trying to find the measure of QTS, so we don't know that. But for SU, we can substitute in what it is, which is 106. Now in algebra, we're taught for an equation like this to get rid of this 1/2. So we're going to multiply both sides by its reciprocal, which would be 2. So multiply the other side by 2. So that gives you 142 is equal to the measure of QTS minus 106. When I take 2 times 1/2, that becomes 1, so it cancels out. So from here, I want to add 106 to both sides. So I get 248 is equal to the measure of arc QTS. All right, let's have a look at number 7. And number 7, a ramp is attached to the first of several barrels that have been strapped together for a circus motorcycle stunt as shown. What is the measure of the angle the ramp makes with the ground? So we have this line and this line intersecting at an angle. Make this a little bigger. Right here, which we don't know. So we don't know this angle. Now both of these lines are tangent lines because this line intersects this circle at one point here, and this line intersects the same circle at one point here. So anytime you have two tangent lines, it's just like when you have a tangent and a secant. Like on the last problem, the angle is equal to half of the difference of the two intercepted arcs. So the two arcs that are inside of this mouth here. So I have this arc going this way, and then I have this arc going this way. Now anytime we know what one of those arcs is, 165, then we can figure out the other one by subtracting that arc from 360, because the entire circle is 360 degrees. So first we would take 360 minus 165. So 360 minus 165, that arc is 195 degrees. So we would set the problem up from our formula, or from the theorem that says the measure of angle, we'll call this x, measure of angle x is equal to half of the difference of the intercepted arcs. We want to put the larger one first. So 195 minus the smaller one, 165. So that gives me 30. And half of 30 is 15. So 15 degrees is the angle that the ramp makes with the ground. Number 9. Assume that segments that appear to be tangent are tangent. So for number 9, we've gone over a problem like this already earlier on. We want to find the measure of angle R. We have two secant lines intersecting inside the circle. So that angle right there, look at the arcs that are intercepted. So inside of this angle, we would have this intercepted arc. And then vertical to it, inside of that, we have this intercepted arc. Okay, so 92 on this side and 51 on that side. Now you always have to set it up from the formula or theorem first, which states that the angle on the inside of the circle is equal to half of the sum of the two intercepted arcs. So 92 and 51. So whenever you see a problem like this, add those two arcs together and divide by 2, and that will give you the angle measure. So that would be half of 143, which is equal to 71.5. So that's the measure of angle 4. Number 11, similar type of problem. So we have the two lines that are intersecting on the inside of the circle. Now some people might ask, well, I thought if this angle is 51, then this angle is 51, but not the case, because this is not the center. Now if this were the center and this is 51, then this would have to be 51, but not when it is not the center. So we have the two lines intersecting inside the circle. So our angle inside the circle, which is 51 degrees, is equal to half of the sum of the two arcs that are intercepted by those lines that crisscross here and here. So one of those angles is 74, the other one I don't know. I'm just going to call that x. So I have 74 and x. So solving this equation, we got to get rid of the 1/2, so multiply both sides by 2. That will cancel out the 1/2. So multiply the other side by 2, and you would get 102. From there, we want to subtract 74 from both sides, and x is equal to 28. So this arc is 28 degrees, which is exactly what we wanted to find, the measure of arc RQ. On number 13, we want to find measure of arc PM. And you might ask yourself, well, which way do I go? Do I go, is this way PM? Or is this way PM? And the way that we know is because if it only has 2 letters, then it's going to be a minor arc. So we want the arc that's less than 180. If it's greater than 180, if it's a major arc, then there will be 3 letters. So this arc would actually be called PRM, or MRP. Alright, so our theorem states that whenever you have, just like with an inscribed angle, when the vertex is on the circle, so that's the key with this lesson, is the vertex of the angle inside the circle, like it was on the last problem, on the circle, as it is in this one, or outside of the circle. So when the vertex is on the circle, then the angle formed is just equal to half of the intercepted arc. So the arc that's on the inside of this angle. So the angle is equal to half of the intercepted arc, which is arc PM, so to solve this, I have to multiply both sides by 2. So that would give me 144 degrees. On number 15, we have the same type of problem, only this time we want to find DAB, so we want to find this angle, but we're given the arc on this side. So you can go about this 2 different ways. You can either subtract this from 360 to get this arc, and then divide that by 2, or you can divide this by 2 to get this angle, and then find its supplement by subtracting from 180. So I'll just go ahead and do it the first way. Since we know that this is 110, let's take 360 minus 110, and the intercepted arc here is 250 degrees. So the measure of angle DAB is equal to half of the intercepted arc, so 250, which gives me 125 degrees. We'll pick up from there on the next video.